This is other concentration unit notes. This is the second part of week 3. There are many different types of concentration units. So far, you should have gone over molarity. Towards the beginning of this week, we went over how molarity equals the number of moles over the number of liters in a solution. But concentration can be measured in a number of different units, in a number of different ways depending on your field of study. For example, air quality testers or water quality testers will generally use parts per billion or parts per million to test how clean the air or how clean the water is. Usually they do this to test the amount of contamination in cities versus rural areas. But today, we're going to be looking at some additional ways of measuring concentration besides molarity and besides parts per million and parts per billion. So we're going to be looking at 4 units to calculate concentration in a solution. The first one is percent by mass. Second one is parts per million. Third one, parts per billion. And the fourth new one is molality. So that is not a typo. This is actually a different formula for concentration, not to be confused with molarity. But before we can go over those 4 new formulas, we're going to review molarity. Molarity is the amount of moles of solute dissolved in liters of solvent. Remember that a solution has 2 parts. The solute is the part that is being dissolved, and the solvent is the part that is doing the dissolving. This is a measurement used in most classes. It's usually the measurement we start with. It is used to measure the strength of the acid, the strength of a base in the real world. And we would use that in acids and bases. We went over this already, but it can be found using the formula molarity equals moles over liters. As an example, what would the molarity be of a solution that is made with 4.25 moles of NaCl and with 2.65 liters of water? We have the number of moles and we have the amount of liters. Therefore, we simply divide one by the other. 4.25 moles divided by 2.65 liters equals 1.60 molarity. Next, we'll go on to the first new form of measurement of concentration, which is percent by mass. Percent by mass can be a useful measurement to find out the amount of solution that's made of solutes versus how much is made of a solvent. This may be used in the real world to set standards of how many items need to be made, like setting how much acid needs to be in a bottle of vinegar. So you'll see percent by mass a lot in foods. I'm sure you've looked at the nutritional label in your cereals or the nutritional label in things in your pantry, and you've looked at the percent of vitamins that are in several different types of foods. So this is where percent by mass is used. The formula for percent by mass is mass of solute over mass of solution times 100. For example, 5.25 grams of NaCl are dissolved in 200 grams of solution. What is the percent by mass of NaCl? We would take the amount of grams of NaCl and divide it by the amount of grams of water. Then we would multiply by 100. This gives us an answer of 2.625%. Our next new formula for concentration is parts per million, abbreviated commonly as ppm. Parts per million is most commonly used to measure the amount of pollutants in air or in water. It's most commonly used by scientists who study in one of these fields. It usually involves a smaller amount of solute or a larger amount of solvent than percent by mass problems. The formula for parts per million, or ppm, is mass of solute divided by mass of solution times 1 million. For example, if 0.75 grams of NaCl are dissolved in 1,300 grams of solution, what is this concentration in parts per million? We would take the amount of grams of NaCl and divide them by the amount of grams of solution. After this, we would multiply by a million. Our answer ends up being 577 ppm. The third new formula for concentration is parts per billion, ppb. Parts per billion is used in the same way that parts per million is used. However, the amount of solute is usually even smaller, or the amount of solution is much bigger than with ppm. The formula for parts per billion is mass of solute over mass of solution times 1 billion. For example, if 1 gram of NaF is dissolved in 140 million grams of solution, what is the concentration in parts per billion? We take that gram of NaF and divide it by 140 million. Next, we multiply by a billion. Our answer is 7 ppb. Our last new formula for concentration is molality. You'll notice that the abbreviation for molarity is a capital M. The abbreviation for molality is a lowercase m. But it's not a regular lowercase m. We like to write it in a slant so that people do not confuse it with the units for meters. Molality is the number of moles of solute dissolved in kilograms of solvent. This is similar to molarity, but a solvent's mass will not change if the gravity of the solvent changes, where the volume might. For example, if you take a solution on the moon. We will not use molality in class as much because we will always work on Earth with constant gravity. The formula is molality equals moles of solute over kilograms of solvent. For example, if a solution is made with 2.35 moles of hydrochloric acid and with 6.35 kilograms of water, what is its molality? We take the 2.35 moles of HCl and divide them by 6.35 kilograms of water. Our answer becomes 0.37 molality.